Okay, so here's the second part of 10.7 video. All right, now we're going to do the same idea where we have x and y and t, but now we're going to talk about word problems, okay? Now, you don't need to know any physics for this. In fact, I'm going to give you, if you look up top here, I'm going to give you these equations on quizzes, test, exam, so you do not have to memorize them. I am also going to give you these numbers for gravity, either in feet per second squared or meters per second squared, so you do not have to memorize them. All right, so what we need to do is we just need to figure out what are sections A, B, C, D of each question. What are they asking? Okay, all right, so let me move this up a little bit. Keep those equations handy. All right, here's number one. Let's see what all these questions are asking. So Mrs. Khan hits a golf ball with an initial velocity of 150 feet per second, an angle of 30 degrees to the horizontal. Okay, so if I come up here and I just start labeling things before I even get started here. The 100 feet per second, well, that's a velocity. And if you look up at the equations, this would be v sub 0, or initial velocity. Okay, and then the angle, well, that should make sense that I can just call that a theta. Okay, and then part A says, find parametric equations to describe the position of the ball. All that means is you're going to give me an x equation and a y equation, both in terms of t. All right, now looking at the equations up top, first let's agree, if it's feet per second squared, we're going to use the 32 for feet for gravity. And if I follow the formulas, let me write the first one out. X is v sub 0 cosine theta t. Okay, so now v sub 0 is 150, cosine theta is 30, and then t. Now in these questions, we're just going to leave t because it's one of our, remember, it's our parametric, it's our parameter. Okay, then a little cleaning up here. I would prefer roots instead of decimals, so you do have to go back to your 30, 60, 90s. Cosine 30 is root 3 over 2, and then t. And then one more cleanup. 150 over 2 is 75. Root 3 t. Okay, and all of these are in feet, so that's the x direction. Okay, now let me just tell you what that means. The x direction we know is our horizontal. So this 75 root 3 t gives us the horizontal distance in terms of time. So after 1 second, how far has it gone? 2 seconds, 3 seconds, 4 seconds. What is the horizontal distance that it's covered? Okay, now if I do the same thing in the y direction, remember, is the height. So this is telling me how high does it go after 1 second, 2 seconds, 3 seconds. All right, so the equation up top, again, you do not have to memorize this one. Let me just copy it so it's right in front of us here. V sub 0 sine theta t plus h. Now, h is your starting height. Where does it start? Now, this one, if I'm hitting a golf ball, we're going to assume the starting height is 0. So this starting height right here is just 0, so I'm not going to plug a number in. But I do have to say, in feet per second, we're going to use the number 32 for gravity, t squared, plus same initial velocity, 150. I'm going to kind of go sideways here. Sine theta, which is 30 degrees. Okay. All right, so we clean it up again. I get negative a half of 32 is negative 16, t squared. Sine 30 is a half. Half of 50 is 75. Oh, you know what? I forgot my t. Let me sneak a t up here and a t in here. Okay, so this is my y equation in terms of time t. All right, now we're going to dive in a little bit further. How long is the ball in the air? Meaning we need to solve for t. So whenever you hear the words how long, you're solving for time t when h is 0. Now that just means when the height is 0. So when it starts on the ground, great. But we want to know when it hits the ground later, how long later until it hits the ground. So if I'm thinking about a height equation, anytime I'm talking about height, we're going to be talking about my y. Okay, so then I'm going to say, okay, if the height is 0, I'm going to set y equals 0 equals this equation we just came up with. Okay, and some of these numbers are pretty, some of them are going to be pretty awful. This one's not too bad, because if I do a little factoring, I take a negative t out, I get 16t minus 75, which tells me time is 0, or time is, well, it'd be 75 over 16. Be a lot easier to write that as decimal, 4.7. Okay, so that means it starts on the ground, that's the 0, and then 4.7 seconds later, it hits the ground again. So if I take a look, let me move this up a little bit, and look at kind of what the graph might look like, or a rough sketch of the graph anyway. Let me do it over here. It starts on the ground, 0. 4.7 seconds later, it's back on the ground again. Okay, so then that leads us into part C. When, okay, so whenever you hear when, that's going to be a time. Is the ball at maximum height? Now, two ways to do this. If it starts at 0, which this one does, it starts on the ground. That's not always the case, but this one does. If it starts at 0, then the maximum height should be right smack in the middle of the graph, right? So it would be like 2.35 or 2.7, however you want to deal with it. Okay, now that's an easy one to see here. So I want to show you what if it's not nice like that. Okay, so if we want to find the max height of the ball, we're talking about a parabola here. So you actually want the maximum, the vertex. So I'm going to say negative b over 2a. Hopefully you guys remember that. That's the x-coordinate of the vertex. So if I take that in this problem, it'd be negative 75 over 2 times negative 16. So there's where I get my 2.3 seconds. Okay, so there's the when part. So 2.3 seconds. I can put that right there. Then it says, the second part, what is the maximum height? So now I want to know on this graph, what is the y value way up there? So then you're going to find y. Let's see, let me do a different color because it's getting kind of messy here. We're going to now find y when time is 2.3 seconds. So I'll plug 2.3 into my y equation. Now you'd have a calculator for this, so just in case you're kind of guessing that, this would be 87.9 feet. All right, so again, that one says, when does it happen? T. What is it? Y. All right, we'll do one more part of this problem here. Okay, now what we're saying in part D is, what's the horizontal distance that the ball traveled? Okay, now let's just remind ourselves, whenever you see horizontal, we want to know x's. All right, so our x equation from up top, let me just recopy it, would be 75 root 3 t. Well, time is when the ball hits the ground again. So if you kind of sneak a peek back at part B, time should be 4.7 seconds. So I had my 75 root 3 times my 4.7 seconds. And then I crank that through a calculator, and I get 610.5 feet. Okay, now we'll do the second one. There's only one other question. We'll do the second one in class tomorrow.